hey, so we've implemented the entropy regularization, and we want some sort of diagnostic to find out like what level to set the entropy regularization. Like, should it be 0.1, 0.01, 0.0001, like how to tell. And so that approach, that thing that gives us a diagnostic is the argmax proportion. At least this is a very helpful diagnostic. So let's talk about that first, and then having talked about it, then I will implement that in code. So let's go to the next clip.
All right, so let's use some slides to talk about this argmax thing. All right, so let's draw a probability distribution. So I'm just going to use a table. So let's say we've got 0.1 and 0.1 and 0.8. All right, now we can draw samples from this. So the samples are going to be the index of the probability, right? So maybe the first sample is 0, like this one, and then the second sample is 1, like this one, and then the third sample is 2, like this one. And then we draw a bunch of 2s, and then maybe a 0, and then a bunch more 2s. And we're going to draw like 2s 80% of the time, right? Because this has a probability of 0.8. Because any draw could be any of them, but like on average, we should be drawing this one 80% of the time. Right, now this is taking samples from the probability distribution. We can also take the argmax. So the argmax is we simply take the most likely action each time. So this is going to be 2, 2, 2, 2, right? It's always going to be 2, right? Maybe I should put these like in separate columns. All right, like this. So basically the argmax is just be 2, 2, 2, 2, 2, 2. Right, like if this is the probability distribution. Now, in the case of our model, the probability distribution is different every single time step. But like, let's just take a particular time step and a particular probability distribution, sampling from it. 80% of the time with this distribution, we're going to get action 2, 10% we're going to get action 0, and 10% we're going to get action 1. With the argmax, we're always going to get action 2 because it's always the most likely action in this distribution, right? If we change this distribution to something else, the argmax could be a different thing, okay? So like let's say we had 0.5 and 0.4 and 0.1, right? So in this case, this would be 50% of the time, but the argmax would always be this one. Like let's just do that for this particular case. So in this case, we would get like 0 occasionally, and 2 a bunch of times, and 1 a bunch of times, and 1 would be slightly more likely than 2, but not that much more likely. Whereas if we do the argmax, so argmax is just going to be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, because this is always the most likely action. Even though it's slightly more, only slightly more probable than this one, the argmax will always choose it. All right, so this is the argmax, and then this is the sampling. Right, now in the reinforce, when we're training, we're always sampling, because that way the model can explore and try different things. So it tries different things, and then the things that works it does more often, and the things that didn't work well it does less often. Over time it learns. If we always did the argmax, it wouldn't learn. It would just always do the same thing every time. It would never ever learn. Right, so during the reinforce we're sampling like this, right? But we're using the entropy regularization to make sure that this probability distribution stays somewhat distributed so that it keeps exploring, right? We want to avoid the situation where we have like 0.0, 0.0, and 1.0, because then the model always does the same thing and it can't learn. Because it has nothing to compare it. It can't be like, oh, I tried this one and it worked better than this one. It's just like, okay, I did that and something happened, right? But it can't learn if it always does the same action, right? Right, now the question is, how much entropy regularization do we need? If we make the entropy regularization too strong, this will be like so random that basically the model is basically acting essentially randomly, and it never does anything useful or interesting. If the entropy regularization is too weak, then we get to this situation where it's always doing the same thing, right? So how can we tell, how do we know what to set the entropy regularization to? So one approach is just like try a bunch of different values and see which one learns better. But that's kind of time-consuming. A slightly faster way is to look at the percentage of time that these samples from the probability distribution match the argmax. So we want them to match the argmax a lot of the time, say 90%, 95%, but we don't want it to be 100%, and we don't want it to be like random, like 33%, right? So what we're going to do is we're simply going to, every single time we take an action, that we take a sample, we're going to look at what the argmax is, and we're going to compare the sample to the argmax, and we're going to calculate, measure the percentage of time that our samples match the argmax. And if that percentage is super high, like 100%, our entropy regularization is probably too weak. We need to increase the entropy regularization, make the model explore more. If the percentage of time that our samples match the argmax is too small, let's say 33%, our entropy regularization is probably too high. We need to reduce it. All right, so what we're going to do is every action, we're going to do the sample, and we're also going to calculate the argmax value, like which action is the most likely, and we're going to see the percentage of time that these two actions match, and we're going to use that as a diagnostic to determine, is our entropy regularization too high or too low. Cool. All right, back to Visual Studio Code.
You know what, let's run this and check that this stuff is working correctly first. I want to run the training of this one, right? And scenario name, defend the center. Alright, so it's got turn left, turn right. Alright, yeah, we intended to do this. Right, so the action probs is 1 through 8, so batch size 1 and 3 possible actions. The step entropy does have a gradient, so that's good. Let's also check that the episode entropy has a gradient, so let's get rid of this for now. And down here, print episode entropy. And I guess we can also print the entropy loss. And then crash. Alright, so the episode entropy has a grad fn, so it wants to be backpropagated too. And then here's the entropy loss, so negative. Cool, alright. So, I mean, we could just run it, but I kind of want to add in the diagnostics because it's really tricky to tune the entropy regularization. And again, from this paper, like if you go to this open review forum for this paper, Emergent Communications Group Negotiation, I was asking a bunch of questions about how to determine the entropy regularization, and this is where they're talking about the argmax. A useful debugging technique is to monitor the proportion of actions taken equal to the argmax action to ensure that the agents are still exploring during periods when the reward has plateaued. We also change, yeah, and they're taking the argmax when they're running the model, but that's a different question. All right, so somewhere we've got the action. This is the action, which is just a number, right? It's just a number between, like, it's either 0, 1, or 2, depending on which button. So this is the second button equal 1. Right, we should get the argmax action. And so we get that by taking the argmax. So we've got the probabilities somewhere. The action probs. So if we do action probs dot max dim equal -1, this will be another integer. So we can print that too. And sometimes they will be the same and sometimes they will be different. Right, so argmax actually, let's dot item this. Oh, we can't item it here. We have to do it here. So it just turns it from being a tensor into being an integer. Alright, so here the action is 0, the chosen action is 0, but the argmax action is 1, right? And if we run that, sometimes they will be the same, sometimes they will be different. Right, here they're the same.
then argmax action taken equal. So if these are the same, then we chose the argmax action, otherwise we didn't. And then, so what we want to do is to count the number of times this is true. So let's say episode argmax action taken equals 0, and we want to know the number. We need to know the number of steps in the episode. We can probably get that from Doom, but it would mean figuring out. Do we have the number of steps? We can probably get it from the Doom object, but I kind of think it's easier just to count, right? So episode steps equals 0. I mean, it would be cleaner to use the game engine thing, but anyway. So here we're going to do episode steps plus equal 1. There's no gradient on this, so we can use plus equal instead of having to do like equal episodes plus 1. Right, and then, so let's do if argmax action equal action, then episode argmax action taken plus equal 1. Alright, so this is going to count how many times the sampled action equals the argmax action. And this is going to take is going to count the total number of steps, the total number of times we took an action. And then the ratio of this to this is how many times we took the argmax action. So let's calculate that. So argmax action percent equal, let's call it episode argmax action percent equal episode argmax action taken divided by episode steps. Alright, and then we'll just, what will we do with that? Should we log it? Yeah, let's log that. So here we're going to log the argmax action percent, and we're going to average out over our 16 episodes, batch average. So we're going to have to measure this per batch. So we've got batch loss equals 0, batch reward equals 0, and then batch equals 0. And so we're going to, each episode, we're going to add the argmax action percent for that episode to the batch argmax action percent. And then we're just going to average it out over all of the episodes in the batch. So where are we going to do that? Probably where we're doing the others. So batch loss, batch reward, batch argmax percent equal, we can just use plus equal here, right? Because these are all scalars. And this is also scalar. So we should calculate this before. Alright, and then the batch argmax action percent equals the batch argmax action percent divided by the total number of episodes in the batch. And then, why is this? Oh, batch average. Alright, so now we're logging this, and we can print that too. So argmax action percent, let's just call it argmax percent. Alright, I think that's ready to go. Let's try running it on my Mac. So it's running like 16 episodes, and then after running 16 episodes, it's recorded. So it's taken the argmax like 40% of the time, well, about 34, about a third of the time it's taking the argmax. So it's basically random at this point. And I guess as learning goes on, this is going to increase. And like, it looks like at the end, it's basically like 100%, like it'll be 1.0. This isn't a percent, is it? It's a proportion. Yeah, let's not call this a percent because it's not a percent. So let's call it, I don't know, like proportion or something. Resetting to 0. So here, this one looks correct. This looks correct. This looks correct. All right, so that's working. Right, and then what happens if I do entropy regularization 0? Like, how quickly does the argmax proportion go to like near 1? Now we're up to 0.5. I guess we'll just copy this up to the instance and then restart the run.
Hey, so we've implemented the entropy regularization, we've implemented the argmax proportion diagnostic, and so the next thing to do is to run this, and we'll start running this in the next video, so I hope you'll see you then.